Hello everyone and welcome to the lecture on Amazon Elastic Compute Cloud, Amazon EC2. So this lecture will contain all these topics. What is Amazon EC2? Amazon EC2 terminology, Amazon EC2 purchasing options, on-demand instances, savings plans, reserved instances, spot instances, dedicated host, dedicated instances, Amazon machine images, AMIs, Amazon EC2 instance types, instance type naming convention, instance families, instance lifecycle, and basic setup. So what is Amazon EC2? Amazon EC2 provides virtual machines or virtual servers in the AWS cloud. When launching an EC2 instance, the specified instance type determines the available hardware, offering a balance of compute, memory, network, and storage resources. Amazon EC2 offers on-demand, scalable computing capacity in the AWS cloud. This reduces hardware cost and enables faster application development and deployment. EC2 allows users to launch as many or as few virtual machines as needed, providing flexibility in instance management to meet varying workload demands. Users can configure various features of their EC2 instances, including security settings, networking options, and storage management, which allows for customized infrastructure setup. EC2 instances can be scaled to handle compute-heavy tasks such as monthly or yearly processes or spikes in website traffic. When usage decreases, capacity can be scaled down, providing cost-effective resource management. So apart from basic definition, EC2 instance is part of virtual private cloud and it is controlled by Identity and Access Management IAM service. CloudWatch is used to monitor the EC2 instances like CPU memory, and you use EBS storage and S3 storage for external storage, and you use elastic load balancers to load balance the traffic between your EC2 instances. So EC2 terminology. So first one, instances. Amazon EC2 allows the launch of virtual machines or virtual servers to run applications, and these are called EC2 instances. AMIs, Amazon machine images. They utilize pre-configured templates for instances, streamlining server setup with necessary components like operating system and software. So as the name suggests, machine images. So basically these are images. If you have worked with VMware or something, you will know that operating system images or snapshot or Docker images. So think of them as same. So you launch instances out of AMIs. Then instance types. You can select from a range of configurations to meet your specific computing needs. So I'll be covering this in next few slides. Key pairs. We need key pairs to manage secure access to instances through AWS stored public keys and privately stored keys. So these are used to log into your EC2 instances. Instance store volumes. These employ temporary storage for data that is deleted upon instance stoppage or termination. Then Amazon EBS volumes use persistent storage options for data via Amazon Elastic Block Store. Regions and zones. So you can optimize latency and redundancy by choosing from various geographical locations. Security groups. So these are used to define virtual firewall rules to control access to instances. So security groups are so you put your EC2 instances behind or inside a security group, and these security groups are basically used to control inbound and outbound traffic through network firewall rules. Basically it involves which protocol and which ports you want to allow inbound and outbound traffic. Then elastic IP addresses. So you can assign static IPv4 addresses for dynamic computing needs. Then we have tags, which are used to implement metadata tags for organizing and managing EC2 resources. And then VPCs, virtual private cloud. These are used to create isolated networks within the AWS cloud for enhanced security and network management. So Amazon EC2 purchasing options. First one, on-demand instances. So you pay by the second for the instances you launch, providing maximum flexibility without long-term commitments. Next one, savings plans. So you commit to a consistent amount of usage to reduce cost with the option for 1 year or 3-year term. Then we have reserved instances. You commit to a specific instance configuration for 1 or 3 years to lower cost further. Then we have spot instances. You access unused EC2 instances at lower prices, offering significant cost savings. So you put a price, something like a bid, and if that price it matches, then you will be allocated. So there is no guarantee because it's not on demand. On demand you are given guarantee that you can take, but you have to give the actual market price, and here you put a lower price. If AWS has extra capacity, they will allocate you. Then dedicated host, wherein you pay for a physical host dedicated to your instances. This is ideal for using existing licenses to save on cost. Then dedicated instances, wherein you pay by the hour for instances on a single tenant hardware, offering physical isolation. So first one, on-demand instances. So I will be covering all the purchasing options. There are total 6. So this is first one, on-demand. So users can enjoy the flexibility of on-demand instances without the need to commit long-term, providing cost-effective computing capacity for variable workloads. On-demand instances allow payment for the compute capacity by the second with a minimum of 60 seconds, offering a precise billing model that aligns with actual usage. These instances are perfect for applications with short-term, sporadic or unpredictable workloads that cannot be interrupted, ensuring reliability and stability. Users maintain full control over the instance lifecycle, deciding when to launch, stop, hibernate, start, reboot or terminate, enhancing management efficiency. For more cost-effective solutions, users are advised to consider AWS savings plans, spot instances or reserved instances, which can offer significant savings over on-demand pricing. So this one has the highest price but maximum flexibility. So you pay on a minimum 60 seconds basis, and whenever you want you use. If you don't want, you are not you will not be charged, but this has highest price and highest flexibility. Next one, savings plans, second type of purchasing option. So savings plans offer a way to save on AWS usage with a flexible pricing model accommodating various compute requirements. These plans allow significant savings on Amazon EC2, AWS Fargate and AWS Lambda, promoting cost efficiency. Differentiated by usage type, these plans offer discounts for EC2, Fargate, Lambda and Amazon SageMaker, ensuring lower prices across diverse AWS services. Commitment to a specific amount of compute power for 1 year or 3 years yields savings beyond on-demand rates, locking in the discount. So it's bit cheaper, but commitment is 1 year at least. Tools like recommendations, performance reporting and budget alerts help effectively manage and optimize savings plans. So you get some tools like recommendations, AWS recommendations, performance reporting and budget alerts. Upon signing up, the usage prices are fixed throughout the term, providing financial predictability and stability. Compute savings plans offer flexibility across instance families, sizes, regions, operating systems or tenancy, including changes in workloads and regions. Next type is reserved instances. Reserved instances require an upfront payment for computing capacity, offering a discount on the hourly charges for instances throughout the reservation term. Users commit to a reserved instance for either 1 or 3 years, providing stability in pricing and capacity over the term. By purchasing a reserved instance, users are guaranteed to have access to the computing resources they need when they need them. Reserved instances can significantly reduce cost compared to on-demand instance pricing, offering financial efficiency for long-term use. Users can choose between convertible reserved instances. Convertible, as the name suggests, allows for changes in the instance type, and standard ones which do not offer flexibility versus higher savings. So there are two types: standard reserved instances and convertible. So standard don't have this flexibility of changing the instance type. Amazon EC2 provides detailed reports and tools for managing reserved instances, helping users track savings and optimize their investments. So fourth type, spot instances. Spot instances offer a dynamic pricing model which allows users to purchase unused EC2 capacity at lower prices, providing a cost-effective way to run flexible applications. Utilizing spot instances can lead to a significant cost savings up to 72% compared to on-demand prices, especially for compute-intensive tasks or flexible workloads. Discounts from spot instances are not limited to EC2. They also extend to other services like AWS Fargate and AWS Lambda, offering a broader range of cost-saving opportunities. Spot instances require choosing between 1 or 3-year commitments, which locks in savings beyond the standard on-demand rates, providing long-term cost efficiency. AWS Cost Explorer and other tools facilitate the management of savings plans, offering insights into performance, budgeting, and recommendation for optimization. Upon signing up for Spot instances, the cost for usage remains constant throughout the term, ensuring financial predictability and built-in consistency. The flexible nature of Spot instances extends across regions and services, offering adaptability in instance families, sizes, and operating systems, ensuring operational flexibility regardless of geographic or computational requirements. So fifth type, dedicated host. So you begin by allocating dedicated host in your AWS account. You launch instances onto this host by specifying the host tenancy, either targeting a specific host or allowing for auto placement. You control where instances are launched on dedicated host and ensure they either return to the same host or move to a different one upon restart based on the host affinity settings. So I will be covering the difference between dedicated host and dedicated instances in a upcoming slide. So you can use AWS License Matcher to create host resource groups for easier management of your dedicated host, which allows for auto allocation and auto release, simplifying the launch process. You can leverage dedicated host for significant cost savings compared to on-demand instances. You can bring your own license for greater cost efficiency and compliance with software licenses. Host resource groups offers flexibility in managing dedicated host as a single entity, simplifying operations like allocation, launch, and release of instances. And then we have dedicated instances, the last one. Dedicated instances are designed to run in a VPC on a hardware that is exclusively used by a single customer, offering physical isolation from other AWS accounts. They allow customers to use their own server configurations, making it easier to meet specific compliance and performance requirements. By providing a physically isolated environment, dedicated instances enhance security, making them ideal for handling sensitive data and application. They are perfectly suited for running business-critical applications that require dedicated resources and stringent compliance adherence. Although they come at a premium, dedicated instances offer a predictable cost structure, making budgeting easier for companies. So this slide will cover what is the difference between dedicated host and dedicated instances. So physical server visibility. So dedicated host. So this one is the most costliest. This is actually, just remember, this is hardware and this is, you don't have hardware. But let's go over the nuances. Okay. Provides full control over physical server. This one, no control over the physical server placement. Instance placement. Instances are placed on a specific single tenant host. Instances run on dedicated hardware without specifying the physical server. So dedicated host allows to bring your own license and visibility into socket core usage because you are getting the hardware also. Herein you get limited license management capabilities. You can use affinity to keep instances on the same physical host. No direct control over instance placement on hardware. You are billed per host regardless of the number of instances running. You are billed per instance based on dedicated instance pricing. This is ideal for server-bound licensing and compliance needs. This is suitable for regulatory compliance or isolation from other customers. Herein you get full physical isolation from other AWS customers. So basically they will allocate the whole hardware for you. This is also isolated from other customers but without visibility into the hardware. So this one, metrics, provides host level metrics like CPU, memory and storage usage. No host level metrics available. All instance types that are supported by the selected host can be launched. And for dedicated instances, supports most instance types but no host control. So this one is most stringent and you get total absolute control and the most costliest also. Herein you are guaranteed that all your instances will be placed on a hardware but you will not be given control of the hardware. Okay, next one is Amazon Machine Images, AMIs. So an AMI contains all the necessary information to start up an instance in AWS, making it a prerequisite for instance creation. So you always start with an image, and from that image you launch an instance. Each AMI comprises of one or more EBS snapshots or a template for the root volume, including the operating system and applications. So in the same analogy as I talked about VMware, so you have snapshot or some images. So when you launch an Linux machine, so basically you have to download some image, and from that image only you can launch an Linux machine. So this AMI come pre-configured with all the operating system applications, and you launch an instance out of it. This defines which AWS accounts are authorized to use the AMI for launching instances, ensuring security and compliance. So you have launch permissions for AWS accounts, and these permissions, so if you create your own custom AMIs, you can have permissions so that only your account can use, and you have publicly available AMIs from which you can launch your regular operating system images. So this details the volumes that will be attached to the instance upon launch, including both the root volume and any additional storage. So AMI contains all the block device mappings for the volume. So it will have some kind of volume, so for example root volume and any additional storage as part of AMI. Okay, next is Amazon EC2 instance types. The instance type specifies the host computer's hardware, affecting the instance performance capabilities. So there are different types of instance types. So first one, so this instance type actually determines what kind of hardware will be part of your operating system. So instance type offers varied levels of compute, memory and storage, and this caters to diverse application needs. So you can choose instance types. I will be covering what are different types of instance types. So based on the type you choose, you will get some kind of compute, some kind of memory and some kind of storage as part of that instance type. So this is grouped by instance family. So based on their capabilities, instance types are categorized into families to simplify the selection process for your application requirements. So you choose an instance type that meets the specific demands of the software or application that you plan to run. Some resources like CPU and memory are dedicated to each instances, while others such as network and disk subsystems are shared. So high versus moderate I/O performance. So instance types are designed with varying levels of input-output performance to accommodate different application needs from moderate to high I/O demands. So instance type naming convention. So we have variety of instance types, and Amazon EC2 offers a wide range of instance types to suit different requirements. So I'll be covering this. So here first part is your, so this is named by family, generation and processor. So instance types are systematically named to reflect their family. For example, C. So this one is compute intensive. Then you have generation. Second part is generation. So it is 7th generation. So this number will change 1, 2, 3, 4, 5, 6. So every time they release a new generation, it will increment by 1. Then we have processor family, which are in this case G. So this I'll be covering what are the different like Intel based, Graviton based. So this is like the processor family. Next we have additional capabilities, which is indicated after after the third letter, and this is the letter before period also, or the fourth letter in the instance type name denote specific features like instance store volume. So this will have some kind of there are different types of additional capabilities. And finally we have size after the dot, and the size of an instance indicated after the period ranges from small to 4x large to 32x large, 48x large. There are a lot of even bare metal also have for bare metal instances, which determines its capacity and power. So this is just one example how to, it always start with instance family, then followed by generation, family, and this one is optional, additional capability. So here are some example. You have M6GD, so 12x large. So this one is dot, and you have R7GNA 16x large. So I'll be covering in next slide all the what it means. So first, just take a look on the right side. You have A. This is for AMD processors, processor family. G is for Graviton processor, and I is for Intel processor. This is the processor family. Basically, you can think of this is like which vendor provides it. So AMD company provides it. This one Intel, and G is AWS own vendor, like their own hardware. So this hardware comes from AMD, and this is from Intel. Then this one is additional capability. B is EBS optimized. D is instance store volumes. N is network and EBS optimized. E stands for extra storage or memory. Then Z is for high performance. Q is Qualcomm reference accelerators, and Flex is flex instance. Okay, next I will be covering all the instance family. So here is the table. So you have instance family, description, processor family, and capabilities. So C is compute optimized, and with C, these are the vendors which are supported, and what additional capabilities can be part of this C. So first one is C. So C for compute optimized, and this is ideal for compute intensive applications. Next come D, which stands for dense storage. This is suited for large data storage needs. F is FPGA for workloads requiring hardware acceleration. Then G is for graphics intensive or graphics rendering. Next is HPC, which stands for high performance computing for scientific and engineering tasks. Next is I, which is for storage optimized, and there are two variations, IM and IS, offering different vCPU to memory ratios for storage heavy applications. Then you have INF, which is AWS Inferentia for machine learning inference. Then we have M, which is most commonly used, which is general purpose and balanced for a broad range of applications. So you can see Mac also, which is tailored for macOS app development. Then P, which is for GPU accelerated for machine learning and graphics. Then R is memory optimized for large in-memory processing. T is bustable performance for varying CPU needs. TRN stands for AWS Trainium for cost-effective deep learning model training. U is high memory for large databases and real-time analytics. VT for video transcoding. This is specialized for media tasks. And X is memory intensive for memory heavy applications. Okay, next is instance life cycles. So when you launch an EC2 instance, what kind of instance life cycle it goes through? So first one is pending. So instance is preparing to enter the running state. An instance enters the pending state when it is launched or when it is started after being in the stop state. You are not built when instance is in pending state. So if you are launching it for the first time, it will go into pending, or from stop you are starting, it will first go to pending state first. Next comes running state. The instance is running and ready for use. You are built when instance is in running state. So this is the only state where you will be charged money. Other than that, all other state you will not be charged any money. 3. Stopping. The instance is preparing to be stopped. You are not built when the instance is in stopping state. 4th one, stopped. The instance is shutting down and cannot be used. The instance can be started at any time. You are not built when the instance is in stop state. Shutting down. The instance is preparing to be terminated. You are not built when instance is in shutting down state. And finally, terminated. The instance has been permanently deleted and cannot be started. You are not built when instance is in terminated state. So this is the basic setup. So how it looks like, the following diagram shows a basic architecture or a basic setup of an Amazon EC2 instance deployed within Amazon Virtual Private Cloud VPC. So in this example, EC2 instance is within an availability zone in a region. So it must be in one of the region or one of the availability zone in one of the regions. So you have to choose at least one AZ where you want to launch the EC2 instance. The EC2 instance is secured within a security group, which is like a firewall that controls incoming and outgoing traffic through a port. So you have port, inbound, outbound port, and what protocol you want to allow or disallow. A private key is stored on the local computer and a public key is stored on the instance. Both keys are specified as a key pair to prove the identity of the user. So on your machine, if you want to connect, you will generate a key pair. Private key you will store on your computer, which you must keep very secure, and public key will be stored on the EC2 instance. So when you connect, there will be a handshake and your computer will automatically provide the private key, and EC2 instance will verify with the public key, and if there is a pair, if there is a match, it will let you log into the EC2 instance. In this scenario, in this particular example, the instance is backed by an Amazon EBS volume. The VPC communicates with the internet using an internet gateway. So once you log in, if you want to download some packages and all, there will be a something component called internet gateway. So if you do sudo yum install or any kind of package manager, it has to fetch some packages. It will go via internet gateway, and you can update the operating system on the EC2 instance. And that's all. Thanks for watching.